Hello, everyone. Welcome to the webinar about JetBrains MPS and about projectional editing in particular. During this presentation, I would like to show you JetBrains MPS, what it is, what it can do for you, and how it differs from the tools that you might already know. It will also get a little bit philosophical, since we believe that the approach that MPS has taken can be quite promising to kind of move programming into the next era, because we believe there's something about the projectional editing in particular that can help in the future to expand and improve the field of programming. So during this webinar, I would also like to talk a little bit about that, where it differs from the current approaches and what benefits it can actually bring. So it's when you look back and you look at how programming and when programming was invented in 1950s, 1960s, when programming was created then, back then, we were not around. We could not influence that process of inventing programming. We just had to accept it. And the common flaw of human brain is that whenever something is and exists when people are born, they take it for granted. So it's natural for us to believe that the programming should be done the way it currently is, and it's difficult to imagine programming done differently. It's simply natural, baked into how the brain works. There's there are several flaws called cognitive biases that psychologists identified in human brain that prevent us somehow to behave rationally. And one of the issues is that we have the tendency to consider the state of the world as it was when we were born as a given, and the bottom line that cannot be actually easily changed. So today, in this presentation, I would like to unroll a little bit back and reflect on the state of programming and show that maybe some things that we do in programming are limiting us, and perhaps we could think of changing them and done differently. But to be more concrete, let's focus on the tooling. Let's focus on MPS, and since MPS belongs to a family of similar tools by different vendors called language workbenches, I should probably explain what these tools can do first, because some of you might not be familiar with language workbenches at all. So I would like to put MPS in context. There are several tools that belong to the category language workbenches. Some of them are commercial, some of them are open source, like MPS. So you can grab MPS from, you can download it and use it for free, or you can go to GitHub, get the sources, and see how it's been implemented. And there are other workbenches. Xtext, for example, is also an open source language workbench. Intentional, on the other hand, is a commercial language workbench, and the company Intentional has been recently purchased by Microsoft. Unfortunately, I don't know any details or future plans that Microsoft has with Intentional, but there might be an indication that this field of language workbenches might have, there might be some potential that Microsoft could see, but maybe we'll see in the future. So language workbenches, if I had to describe what they are for people who've never seen them and who, I assume, come from the programming background, so you can think of language workbenches like IDEs, where the languages in which you write your code are flexible, modifiable. You can define them, you can change them, you can combine them. So language workbenches have the capabilities to define the languages in which you will write your program. And once you set off to write your programs, you have similar capabilities that IDEs can provide. So unlike in IDEs, you can create new languages, you can extend existing languages, tune them to your needs, make them better, and you can combine languages. I'll illustrate that with a few examples here. So let me start with the capability to create a new language. Okay, here's an example of a very simple language. We call it robot Kaya language. It is a language that used to be used for teaching programming and basic algorithmics. So it's a very straightforward language that can through which you can command a virtual robot to walk around the screen and do things. So when I run this script, I'll get a visual rectangular area. Let me run it. So now I've got an area and the robot will follow the script and walk around the screen and fulfill the tasks that are encoded in that little script. And in that script you can, I'll switch that off. So you can command the robot with with simple commands like step, turn left, turn right, and you've got control flow statements like while or if. And such, and some conditions to check whether there's a wall ahead the robot and such. So the language is pretty straightforward, and I didn't invent that language. I just copied the language that had existed for many years, and I implemented it in MPS so that I can write code in MPS now. So you see on the left side there's this the place where the IDs from JetBrains typically show the structure of your project. So on top of what you normally see in IntelliJ IDEA, for example, you also see nodes representing languages. So not only you have modules that represent pieces of code, the two nodes at the top, but you also see languages that are part of the project. So as part of the project, I created languages and then I use them right away in the same project. Sometimes, obviously, you don't want to create language as part of your project. You just want to download an existing language from the internet or grab a language plugin from the JetBrains repository. That is also well possible. So in the plugin section that all our IDs have for MPS, this way you can install new languages that someone else created, and then you can use them in your code. And for the languages, you get full ID support. So the things you know from other IDs, like code completion with control space, navigation to definition, so you can do Control B and it will get you to definition of things that you refer to. You can search for usages, highlight usages, change names of things, and it would just work like in all other IDs. It has also the capabilities for code analysis. So if the language author who created this language identified several error patterns, so common patterns that indicate potential error in the code that user has created, they can provide rules to report to the user. So something like static code analysis in IntelliJ IDEA, where you have like 1,000 or so rules that report various potential problems. Well, you can create those rules for your languages as well. So, well, for this simple language, there's just one little example of that. If you unnecessarily duplicate one command twice, then you get this, yellow underline, a warning telling you, well, consider using repeat instead of duplicating, the command. And if the nature of the problem allows it, you can Alt-Enter and fix it with a quick fix. So then you have, the code refactor into the correct form. I mean, correct by as defined by the author of the language. So part of the language definition is also the static code analysis rules and quick fixes for them. Well, another example I have is language extension. So not only you can create completely new languages and then let users use them, but you can extend languages that others have created. So an example of that would be, for example, here, our partners, they created an implementation of C. C is a programming language, so it can be implemented in a language workbench like MPS. But once you do that, you can have that language, you can allow that language to be extended in many ways. So, for example, you can add math notations so that the language not only supports full C syntax, but on top of that, you can use math notations to represent math formulas, which can simplify life in certain kind of applications. Not in all of them, but for some, this can be a very convenient improvement of that core language. Or you can extend the type system of a language. Languages like, well, any general purpose language, in fact, they can't support domain-specific things easily because you can't change those languages. But with Language Workbench, you can, for example, adapt C for programming avionics or programming some robot control in real life, where you have positions, you've got some coordinates, X and Y coordinates for a robot to move around some building, for example, and then obviously position has to be expressed in meters. But all a programming language like C can offer is integer, signed or unsigned, whatever you like, but still it is an integer. And if you represent kilograms, you also use integers. So easily you might make an error. You might make a mistake in your code where you mess up with between kilograms and meters because the type system has no idea whether a variable, the integer variable contains kilograms or meters. But if you extend the language, then you can mark particular data structure that, or particular variables. You can annotate the type with the actual physical unit, and then the type system is able to report any violations of type system rules based on physical units. So now when you compare meters and non-meters, or meters and kilograms, the type system will complain that this is not possible. While if you correctly annotate your values and parameters as integers holding meters, then the type system will be happy. So that's an example of one little extension that can make code for certain kind of application checked by the type system, and thus slightly more likely to be correct. Well, the third example of what languages can do, or language workbenches can do, is combining languages. So this is an example taken from the Java world. So simple Java class, and Java defined in MPS now can be extended with things like math notations, physical units, or money literals. So you can type things like 10 euro, and you can add it. You can add values like this, and operate with money in a slightly more convenient way. So it's a little improvement which might be worth it if you write certain type of financial applications, right? But might not be useful for other types of applications. But then another possible extension could be a decision table. So you've got a little table that, depending on the outcome of calling these functions, will return true or false for individual cells in that table, and depending on which column, which row returns true, the decision table will return that particular value. So instead of having nested if-else statements, you can express the same semantics using these more succinct and convenient syntax. But ultimately, this will all be generated into Java code so that Java compiler can run it. But the languages, the two extensions, the MoneyLiteral and the decision table, can be nicely combined. So, so the capability of language workbenches is that you can grab languages or extensions, possibly by different vendors, and use them together without ambiguities, without clashes. That only some language workbenches can do, and obviously those who see slightly, who know more about this field, then now you know that this would hit the problems. It would hit problems if you were using parsers and using Projectional editor, and that's what MPS is about. That avoids that problem. So thanks to Projectional editor, we don't have the issue of combining parsers of different languages into one parser that can parse a combination of these two languages. I promise this will be a little bit philosophical at some part. No, yeah, that's the part. When we look back how programming was invented and when it was invented, the computers at that time, they were actually very expensive. So you did not have a computer on your desk. You had a computer terminal, or you could do, and that terminal was connected with long wire that went to the computer. The computer was elsewhere and was shared with several terminals. And so programming had to adopt to the user interface, which was sequential and text-based. So all you could do was type in characters, and ideally you had to do it sequentially so that they could go over the serial wire to the computer easily. So, from that time, most of the, the languages and approach compilers work, it was created back then with these devices being the state of the art. Now, since then, obviously things change. Now we've got our own computers, we can interact with the code through IDEs, and programming is no longer sequential. Now, here's just a little illustration of what I have in mind when I speak about interacting with the IDE. This is good old IntelliJ IDEA. Many of you know our IDEs, so you'll be familiar with this. And I write a little piece of code with no particular meaning, just to illustrate the process of creating code with modern IDEs. So, you create a method. If I want to iterate over the arguments, I do it using live templates. Then I know I need to parse it, and there's a method for this somewhere. So code completion is smart enough to figure out, what possibly I might want to call from here. I want to parse arguments, and I want to store it in a variable. Now, this might potentially throw an exception, so I'd better check it. Maybe I want to print this value out. Maybe I would like to start this in a new thread, so maybe I should wrap it with a runnable and start new thread, pass the runnable in, and start it. And yeah, maybe I want to refactor this and make it an inner class instead of an anonymous class. So I trigger a more involved refactoring to do that, and I could continue. So the thing I wanted to highlight here, that although I was writing code, and the code is a text document after all, I was not typing characters left to right, top to bottom, but I was instead interacting with the IDE, invoking actions from the IDE by hitting various key shortcuts in the keyboard, on the keyboard. And I only typed in the important, the essential information, and the rest was filled in from my intentions that I expressed through typing. And I wasn't using any advanced functionality of the IDE. I think most of IDEs today can do things like that. Even little things, like declaring a variable, right? If you declare a variable, final integer a equals 5, semicolon. If you go left to right, you have to type certain number of characters to have that thing inserted. But the essential information here is 5. That's the value you want to store, and the name of the variable. That's something the IDE cannot guess. The rest is easy. If you just tell the IDE, I want to have a variable. The value should be 5. The name should be a. So you can do that. If you know your IDE by just typing 5. I want to have a variable. The name should be a. So just one little simple refactoring, and if you learn that one, you can simplify your life as a programmer. You can become a little bit faster. And but obviously there are more refactorings which, if you internalize, you can become more fluent in communicating with your IDE. So that's what I mean by interacting with the IDE. The process is no longer typing text; it's more interacting with the tool. But inherently, there is still the text document is still there. So schematically, if you interact with your IDE, you edit a text document through some fancy text editor. The text file is saved on disk, and the IDE has to reparse it. Each time you change something, or when you start your project, it will reparse your text files and will build a data structure that will represent your code. And then you save it as a text, and the compiler then will do the same. Will parse the text, build some data structure, and then through a series of steps, it will modify it and change it into some binaries that then you use as the output of the compiler. Now, I need to spend a little bit more time on these data structures, because not all of you might be familiar with them. With the data structure called abstract syntax tree, what it is, how it looks like. And it will be essential for to continue in this webinar, so I need to mention this. So in programs like compiler and IDE, these represent your code as a tree structure. The tree naturally represents any piece of code. So you've got a root, which in Java would be class, in C it would be perhaps, you know, file. And in that root, you've got children. Like in class, you've got methods. And now these methods have other children, like parameters or body. The body, you know, of statements. Some of the statements, that could be an if statement. If statement has a condition, has a true branch and false branch, and so on. And so you sort of nest deeper into the structure of your code. One of the oldest languages, Lisp, they didn't have parsers, so they used parentheses to demarcate the boundaries between the nodes out of which the tree consists. So even the textual form of that language, the form that the programmer interacted with, that directly corresponded to the tree that the compiler or the tooling will then build. Or if you look at the graphical tools that these days are used for teaching programming, mostly to kids, you see the same approach. There's a palette of some components. They differ in shape, they differ in color, and you drag and drop them with mouse and to build your script, to build your little program, and you fill in only the things that are important, right? So you just drag a variable declaration to your program, and then you fill in the name, you change the name, and you change the value that you give it, just like what I've done in IntelliJ IDEA, you know, a minute ago. So it's the same approach. It's just that for effectiveness in IntelliJ IDEA, we do not have a palette. Well, actually, we do. Code completion is the palette. So we have a palette, but it's context sensitive. It's not that colorful. But still, we have the palette, and you don't drag it with mouse, but you do it with control space and then enter. And yeah, and then you fill in the things with the keyboard. You don't need mouse. But other than that, the approach is the same. You know, a language is a set of these components in some palette out of which you drag them somehow into your code, and you combine them, compose them into a tree-like structure. Now, if you look at any piece of Java code, thanks to indentation, you will also see the tree structure there. The indentation is there mostly for us, for programmers, to understand the code better. Obviously, the compiler doesn't need it. So you see that there's, there is some hierarchy to this piece of code, and some tools can even visualize it for you. So you can then see, how the program will see your program, how it's structured, and how the parent-child relationship in that tree holds. So, for example, if you have an if statement has 2 or 3 children. One is for condition, one is for body, one is for the alternative, the else branch. Now, on top of this hierarchy in the AST, there's also the notion of references. So each time you call a method or you refer to a variable, you need to have a reference to what you actually call. A method can be defined somewhere else in the class, in place other than the place where we call it. Or it can be defined in another class, so then the reference would point to another tree. So this is, these references, if you add these references, then you actually get a graph, not just pure tree, but you get a graph that represents your program. And then looking at languages, well, language is a set of components out of which you can build your programs. Either a graphical palette, or could be some virtual palette of things that appear in a completion menu if you do control space. And these things have to be defined somehow. In visual tools, in Scratch, they are defined as graphical symbols of certain color and shape. In a compiler, here's an example from the Groovy compiler. In a compiler, they are represented, by some programming constructs. In object-oriented languages like Java, they are represented as classes. So the compiler has a set of classes, each for a language element. So one for if statement, for example, that holds 3 fields: one for the condition, one for the if block, one for the else block, and and then it has another class to represent statement, another one to represent expressions, and so on and so forth. Well, in MPS, we have a similar capability. So in language workbenches, you also have to have a capability to define the things that will be in the palette. So if you want to define an if statement for your language that you're building with JetBrains MPS, well, you use a language that looks like an object-oriented Java class thing. You give it a name, if statement. It has some alias, so it's like some visualization in the completion menu. And it has 3 children, one for condition, one for true branch, one for the else branch. So, and your concept can inherit some qualities from another concept. So the language for defining concept has a notion of inheritance. So it's just like an object-oriented way to define languages. The MoneyLiteral I showed you earlier, the thing 10 euro and 20 USD. If you want that thing to be in your language, well, you would probably define it in a way similar to this, right? So you would have a property that of value integer where you store the actual amount of money, and then you would have a reference to some set of predefined currencies that the user can have in her program, and and you pick the reference from there. So to put it all together and finish this theoretical insight into the data structure, you have to distinguish in language workbenches between two things. There's the left part, which is the program, or we can call it a model. So this is the thing that programmers create. And then you have the right side, which is the language, the meta level. This is where the languages are created. And each node in your program is of certain kind of a language concept. So it always has to know the concept of which it is an instance. Okay, so now now I would like to ask you if you have any questions, or if we've collected any questions so far, I could answer them before we move on. So are there any questions?
Yeah, Václav, actually there's one question now. Is which of the 3 mentioned capabilities of languages workbenches do you consider the most important or innovative one?
Oh, yeah, I think, well, I mentioned 3 of them, right? You can create new languages in language workbenches, you can extend languages, and you can combine them. And I think the ability to combine languages is probably the most impressive one. Because there are tools that allow you to create languages. There are excellent tools to create external DSLs already there. But if you want to grab 2 almost random languages that make sense to use together and have a technology that allows you to do that, I think that is sort of innovative, and it's a direct implication of projectional editing. So yeah, I think that would be my candidate. Okay, are there any other questions?
Not at the moment.
Okay, good. Let's move on. So back to the scheme, right? Back to the scheme. This is how programming is currently done in the mainstream and how it's been historically sort of invented. So you interact with a textual document that is then being reparsed, and then this data structure that we just talked about is built from a textual representation. Now, there are things that have changed since 1950s, right? We've got more powerful computers, we've got different devices through which we interact, and with the programs. There's there are touch devices, there are devices able to capture our gestures or recognize voice. So maybe that could be also useful to input, somehow influence the process of programming, but you can't do it if your programs needs to be in ASCII symbols and parsed by a parser. So maybe things have changed, and maybe we should reconsider some things about programming, and try to do them differently. What if we just can't move forward the same way? Maybe we need to. Sometimes it's good to reflect on the situation and try different paths. Maybe the field of programming is now in some local optimum, because programming, after all, is quite efficient, and we've done a great job in making our tools effective, and we're tuning our methodologies and processes. But maybe we've just reaching local optimum, and if we want to reach a global optimum, we need to undo and redo differently some fundamental things about programming. I'm not offering an ideal and prepared answer. I'm just giving you suggestion, and I'm showing you projectional editor as one possibility to look at and consider whether that might have some impact in on the way you do programming, at least on some projects. So yeah, maybe just the view how we currently define programming is a bit too narrow. Maybe there are other domains that could benefit from the things that we've developed for programming, and they cannot yet, but maybe there's just little change needed so that the other domains, the other fields, could also benefit from things like continuous integration and testing and explicit, the declaration of functionality. That, that's what we do, and that's what mainstream programming is about. But there's some other areas that still have struggle. So we've looked around and found several examples of domains where the current approach doesn't work well, and we realized that the language workbenches could help there a lot. So if you happen to work in one of those fields or similar areas, then you might consider using language workbenches on your projects as well. So I'll give you one example first. It's an insurance company in Germany that they've got a department of financial experts, and they write rules to run the insurance business. They understand insurance. They have some technical background, but they're not developers. So they write in Microsoft Word. They write these documents that describe the rules. And the rules themselves, they look like typical piece of like a function in a programming language, since it has a name and types and parameters and documentation, believe it or not, and it has a body, which is like some sort of expression or combination of expression and statements to specify the desired outcome. And this is then saved as PDF, sent over to an outsourcing company for manually coding into some programming language. I believe it's C. And that C code is then sent back and integrated somehow in the code base, which is quite a lengthy process and error-prone, I believe. And also versioning could be quite a problem, to make sure your PDF documents match the actual C code that you get back and what version is what. So with the language workbench, they can use an IDE with a language that mimics the behavior of the Word document. So they don't have to learn new syntax. It still looks pretty much the same as they did before. Now on the left side you see the new thing, on the right side you see the old thing. And but they've got IDE support, so they can control space. They have error highlighting. They have the code analysis. They can use math notations, and other bells and whistles so that we are used to in IDEs. They can test their code, and they can just hit compile, and it will generate C code, and that C code can be compiled and run. So there's no need for manual coding. And this code that that they create, the one the document on the screen now. So this is something they store in version control. So they're using Git, so they use the state-of-the-art technologies to keep track of versions and to maintain their project. Well, then we've got two customers who operate in the domain of tax software and the legislation for tax. So they have to have running systems that calculate taxes every month. And the software has to reflect legislation, and the legislation has to, the legislation has to be, the legislation has to be encoded in that program correctly, so that you can reliably calculate the proper tax every month. And you've got people who understand legislation, and you've got people who understand programming. So how to combine this, right? The typical scenario is you have these two groups docked together, and then hoping that the programmers will implement the rules correctly. With Language Workbench, you can let the technically savvy legislation experts using the languages that the software developers prepared. So using those languages, they can encode pretty directly the law into their models, and then have the language workbench to generate that into Java, that then can run every month on a server and calculate tax. Last example from healthcare. Now, imagine, imagine that people who suffer from certain diseases and have to be treated with very expensive and very powerful medicine. They have to be in hospital in order to take that medicine, because it has to be dosed very carefully. Now imagine there was a mobile phone application that could monitor the health state of the patient through some variables, and could indicate to the person the right moment and the right dose of the medicine. Then the people wouldn't have to stay in hospital, or at least not for so long. The thing is that this software has to be certified, just like the medicine has. So you have to prove that your software will do what it claims it will do, just like the medicine. So you have to have you have to have government to certify that this program will work. So the code has to be understandable for non-programmers, for domain experts, doctors, to actually give the certification. So again, this is an opportunity for a tool that separates the model domain, medicine, and the implementation domain, Android or iOS. And so on one level, the doctors can verify the rules because they understand them, and on the other hand, you've got generated code that can run on the mobile devices. There are more customers that experiment or use MPS already, and they use MPS and or language. I can speak for MPS. Obviously, I don't know much about the customers of other language workbenches, but I believe they've got a similar set of customers in various domains. And these customers, they benefit. They benefit mostly from the increased productivity, because you've got you have domain experts directly interact with the IDE or with the language and define the rules. You've got quality, because the process of how these rules are encoded into the target code, C or Java, are prepared and tested by the most senior developers you have in your team, and then thanks to the separation of the business domain and the implementation domain, you leverage expertise of both groups. You leverage the expertise of your domain experts, and you also that's encoded. The expertise is encoded in the models, and then you also leverage the expertise of the developers who understand the target domain, because their knowledge is contained in the generator, the process of how that high-level model gets translated into Java or C. Here's a little example of, I can't show you examples of these particular client languages, but I can give you an example that sort of catches the essence of all these tools. And we all should be familiar with this. That's why I chose this example. It is a language for defining voice menu. We all know voice menu. If you call a bank, you've got some automated set of replies. Press 1 for this, press 2 for that, like nested submenus. So we created this language that allows the administrator of the voice system, who's not necessarily a programmer, to actually declare such voice menu structure easily. So I've got here some dummy JetBrains call center. If you press 1, you go to sales. If you press 2, you go to some other department, and you might go on. So if you press 3, we will go to technical support. Now I can press this little button here. It will create a technical support, which is a menu, and in that menu, technical support is for IDEA. So for IDEA, you'll get a direct connection to the IDEA support person. for web. So if you press 2, wrong place. Here, if you press 2, you will go to the WebStorm support person, and yeah, we might call directly that person. The extension there is whatever, and you know this code. So this is the definition of the menu. Obviously, you can't run this. This is to make it easy for the administrator person to create that menu. And then in the process of generation, a set of files is created that is used by the system that we have at JetBrains called asterisk, which accepts this format as definition of the voice menu, and you upload it to the server, and your voice menu now changes to whatever you have in your definition, right? So this is the essence. You separate this, which is the knowledge of the domain. This is how we want to serve the customers. From the implementation, this is the system we have currently, and so this is what we have to create. You can either create this file manually and upload it to your server, or you can create a language that makes it easier and have a generator that will generate this. Now, if you want to, and you have several options. You don't have to generate that one format. I can switch to XML, for example, and now I have XML generated. So let's assume we've got some other system that accepts XML as a definition of the voice menu. So yeah, here it is. I upload it to the server, and the voice menu will change to this. And for debugging, we've got HTML. So I switched to generating HTML. So now I generate HTML, or well, I can rebuild this way and then open it in a browser, and I have some visualization of the structure of my menu. Or I can switch to Java, and that's the coolest one. So I switched to Java, so now I'll generate Java from this. So here's the Java class that gets generated, and that allows me to run it. So I've got a little simulator that simulates a phone, and now I can press buttons right here, and it will speak to me. Unfortunately, you will not hear that that voice because it goes into my headset. But yeah, you can speak to you can press buttons. It will speak to you thanks to voice synthesizer, so you can easily verify whether the voice menu does what it's supposed to do. So this is just an example to illustrate the potential usages. Obviously, the usages are in many different areas, many different domains. But the essence is that you create high-level language in which people can create their languages, and then generator that will create the implementation, which can be XML, Java, property files, PHP, whatever you like. Now, obviously, if you go this path, there's some upfront investment you have to make into building the languages. Unlike just starting, in Java or C right away, you have some initial upfront investment to make to build your languages, and then hopefully, that depends on how well you design your languages and whether you choose the right domain where to apply language engineering. So if you do it correctly, then the progress should be smoother and faster than using the general programming language approach. But obviously, you have to pick the domain where this makes sense, right? So this is not a panacea to solve every single issue in programming. It's more like if you've got situations like that one where you've got high-level knowledge that you would like to be preserved, you've got domain experts who are not programmers but would like to understand the code that you create, or even you might want to have them create that code sometimes, then this might be worth considering, taking language engineering for a ride. But it really depends, whether you'll be reusing that language frequently or not. Obviously, you don't have to build all languages up front and only then start development. MPS supports a gradual evolution of languages, so once you create a new version of a language, you can update automatically all usages of your language, so people can continue, with new version of your language, continue their development. Now let's look into what is specific about MPS, and that is the projectional editor. But this editor tries to eliminate the inherited textual processing part of the whole process of writing code. So instead of the programmer trying to describe the thoughts in her head through ASCII symbols to, and insert those into a text file so that the tool can then parse it and build the data structure it needs, the projectional editor allows the developer to directly manipulate that tree. And by invoking various actions through keyboard shortcuts, the tree is manipulated directly. There's no textual processing whatsoever, and so you don't have to force yourself to express your thoughts in textual form in ASCII symbols. You can use rich syntaxes, graphical symbols, diagrams, tables, and things like that pretty freely. So your code is always your code is always in the tree form, never in the textual form, and you interact directly with the tree. So when you write your code, you just with your keystrokes, you're invoking actions on the in MPS to change the AST, not to insert characters and then let the IDE to reparse and understand again, but to actually rebuild and rewire the tree. And and then the process continues. You generate some Java, XML, C, or whatever code that you have a compiler for, and compiler will pick it up, compile, and generate binaries. So the major distinction is your code is always in the AST form. Obviously, we could pass that AST to the compiler directly. We could do that for compilers if they provided an API to do that, and if the AST was identical. So that's more like currently it's more like a theoretical question for the future. But that's not limiting us. I mean, the generation process, this thing that the compiler has to reparse whatever we generate, is not a problem. Now, actually, it's an advantage because we want to integrate with existing code base. We would like to make typically the domain-specific language part of your project is just a portion of your project, not the whole. So you want to integrate with some Java code base, and you would like to have some stage where you have all the generated and manually written Java side by side before you run the compiler. Okay, so here's an just small illustration of how Projectional Editor actually works. You can look at the code as the code it from Java. Variable declaration here, a equals 1 times 2, but that is not actually the code. The code is the tree, and the tree grows as you keep typing, and it changes as you type. So if I go back to MPS and into here. So now if I create a variable, so now I can visualize. So although this looks like text, if you look at it, and you can't do anything, just look at it, I can interact with it, so I can feel the difference. So like if I hit backspace, in IntelliJ IDEA, it would delete the semicolon, but here it does not, because without a semicolon, that wouldn't be a valid piece of code in Java. That would be invalid immediately if I just delete the semicolon. So instead, I have to delete it all. But to give me some hint, now MPS will highlight it in red, telling me, yeah, if you continue like that, the whole line will be deleted. Do you want to do that? Yes, sure, or not. Or if I keep typing now at the end of the line, I'm typing, but nothing's happening because simply, there's nothing that should be inserted at this part, in this part of code. So the projectional editor is sort of guiding me and guarding me how I can interact with the code, which might be limiting for general purpose programming. I admit that, and that's why I currently believe, this is more relevant for domain-specific languages. Now, since the editor provides just visualization or illusion that hides the real code, which is behind the scenes as in the form of a tree, the editor also can be suppressed, and then you can reveal the tree structure directly in the editor. So now when we turn on the reflective editor for this particular part of the code, now we see that part of the code as a tree, not as the text that is, you know, the default editor for this for these concepts. So we see that the initializer currently is an integer constant of value 1. Now when we get back to the default editor, so now code looks like text again, and we keep typing, the characters that we type on the keyboard, they are translated directly into actions, into transformations of that tree. So now 1 times 2 is what we see on the screen, but in the code we've got multiplication expression with 2 children, left expression and right expression. Left is an integer constant with value 1, right is an integer constant with value 2. Well, we can further suppress the editor and use the reflective editor for these integer constants as well. So we now see the tree unroll in the editor. You know, if we continue this way, you will see, you know, the tree automatically changes, reshuffles based on priorities of these expressions. So now we end up with plus expression with, on the left side, multiplication expression of 1 and 2, and on the right side, the integer constant value 3. Now this direct AST manipulation gives you rich syntaxes. So now, since you don't have to make the parsing possible, you can create, you know, tabular notations. You can use symbols in your code, or you can use positional notations. So notations when if something is in the upper left corner, it has certain meaning, and, you know, the meaning could be different from when it is in the, you know, lower right corner, for example. So something like Microsoft Word based on form notations. You could define several notations for a single language. So you could have a language that has several possible visualizations, and you let the user to choose the one they prefer. So like this is a simple state machine language, and you can edit it in a textual form or in a tabular form. You switch between these two depending on, you know, what your preference at the moment is. You know, so you might have one notation for editing code, another one for debugging code, for resolving merge conflicts, for reviews. So now when the notation is detached from the actual structure of your language, you can choose the visualization that is most appropriate for the task. You can either target, you know, a notation that's more efficient to type, or a notation that is more instructive. It's more chatty, gives you more guidance. It's slightly less efficient to use. You don't have to make the trade-off in the notation. You can have both. And you can combine languages. If languages are not parsed, you can combine languages, even languages with incompatible notations. So you can have graphical nested inside textual, textual inside graphical. So that is all possible if the language does not need to be understandable by a parser. So these are the sort of benefits that you get from Projectional Editor. To make the picture complete, right, I have to kind of say a few words on how languages actually are defined in MPS, because so far I only told you very vaguely that, you know, you define some concepts, but there's certainly more to it, right? To define concepts is the first part. This is like, I have to define what constructs are allowed in my language. So I will have an if statement, I'll have a method declaration, I'll have a class definition, you know, things like that. So you have to define these things. And this is the language to do that. The language looks like an object-oriented language. You define a concept called if statement. It inherits some qualities from another concept. It has some children. So in the tree, when someone creates an if statement, there will be 3 possible children of that particular, you know, if statement. One for condition, one for true branch, one for false branch. Or MoneyLiteral. There's not children but properties, so there's no complex to express the amount. You can only say an integer. You can give an integer value and that's it. And to express a currency, you have to point to an existing currency. So there's somewhere, I assume there's a list of currencies and there's a reference to it. So this is like the cross pointer, not the hierarchical one, but the one that points to some other place of your code. But once you have that, you have to define the editor. You have to define how this is visualized to the user, how the user will interact with the ASD, with the model. So like for an if statement, now speaking of if statement, so yeah, let's continue with if statement. The if statement in the robot language, right, has an editor definition that looks like that. So it mimics the result. The result in result, you know, the if statement on the screen will be laid out in this way. So we'll have a keyword if, then we'll have a place where the condition will be, and then the keyword do, and then on the next line, slightly indented, we'll start the true branch. And then on the next line, we'll have an end, and then else, which is optional, might not be there all the time. So if I go to the robot language, so you know, here's an if statement. If we look at it, this is the concept definition that I've shown you in the slide. So this is definition of an if statement, and well, here is the editor definition for this. And so the if statement as it's defined here quite resembles the if statement as it's shown here. And if you change something in the definition, let's say instead of do, I would like to use the Java way, and instead of and also I'll use the curly braces. So yes, you can change the editor definition that way. So we change the keywords, and yeah, as soon as I rebuild my language, I change the language definition, the visualization of my code in the left panel changes as well. And so now I see curly braces here instead of the do and words there as well. And if you want to make a condition in some background color, you can do that as well. So we can have a background color defined for the condition. So the condition will be marked in green. So now I changed the visualization of my code. So that's the purpose of editor. Obviously, the editor can do a lot of things. This is just scratching the surface to showing you, the effect of changing the definition of an editor for a language. Yeah, for the MoneyLiteral, the editor is even simpler. It's just show me the amount and then show me the name of the currency, and yeah, and all nicely side by side, organized horizontally on one line. Okay, so we'll leave questions till the end. We're almost there. The last thing to cover is the generator. The task of the generator is to translate, to go from the expert domain, the business domain of your language, into the implementation domain. So this is the part in which the most senior developers that are on your team will be needed. Right? They will have to generify what they already do. So if they write systems for that particular domain already, but now they do it on ad hoc basis. The domain expert expresses the intentions, their requirements, and the programmers encode them, and then they encode another requirement. Now, with this approach, it's more like preparing a generator that can generate the future requirements. So you take the same. You have to have that knowledge, that rare and valued knowledge that programmers have, and you focus that knowledge into the generator, so that the knowledge is encoded in a reusable way, so that then the knowledge can be used for future scenarios. When the domain experts come up with new discounts for your eShop, they come up with new ideas for the voice menu, right? So now they have the generator ready to generate optimal code, even when the programmers who've created the generator are now busy doing something else. So it's encoding the knowledge they have in a reusable way, so that they don't have to encode every single requirement again and again. So the generator is primarily focused on changing the ASD. It's focused on taking the ASD and changing it into an ASD that is closer to the implementation domain. And then the final step is flush out the text. But the textual part is not that important. the textual part generates the actual Java sources or C sources or XML sources, whatever your outcome, the result should be. And in order to go there, you have to have a definition of that language in MPS. So for Java, we've got base language. We call it base language, but it's a copy of Java. It's a one-to-one copy, and that language knows how to translate itself into textual Java. So it knows the rules, how to take an if statement and then flush characters, if, parentheses, and so on, into the buffer for the output, for the output buffer. But where it becomes interesting is the part when you want to generate that language, when you actually have your domain specifics, your domain specific language, and you want to change it into base language or into some MPS based C implementation or some other language that is implemented in MPS, some general purpose language, because this is the place where you have to create the generator, and the generator will translate. The generator will translate things from high-level concepts into the low-level concepts, preferably in several steps. And ultimately, you can target several target languages, either at the same time because they are all needed together. For example, in web applications, you would need XML, HTML, SQL, all this output to be generated. Or you might pick the target that you want. Like the voice menu example I showed you earlier, I picked HTML if I want to visualize a thing, Java if I wanted to simulate a thing. So it goes in steps and gradually transform more to implementation. Example of that approach. Getting Java compiler asking about in 10 USD or 10 euro. So somewhere around the way during the generation process, the AST that held 10 euro translated into a very similar AST in this case, because it's both almost, the language is just a small extension to Java, so the trees are very, very similar. Just the part that represented 10 euro has to be replaced with the proper way how to do it in Java. So perhaps new money, you create a new instance of the money class and you pass it two arguments, the first representing the value, the second representing the currency. So this way you replace the generator can now replace all MoneyLiterals in your code with proper Java way to do things. And similarly, you would replace other extensions, like decision table will be replaced with the nested if statements. And then that's something that Java compiler can understand. Okay, so we're almost done. I should probably mention that if you would like to use MPS or other language workbench on your project and try language engineering, there's some effort to it. You have to design languages, and that is not a trivial task to do. There's certain skill set that people have to have in order to create good languages. And not only languages that cover the domain properly, but also languages that are convenient to use, and also that are well generated into the implementation domain. So it takes effort and it takes some learning before you can actually embed and before you can go this path. And obviously there's cultural challenges as well, because now with language engineering in place, things become different and maybe more complex on the integration side, because that's one more extra tool to add to your infrastructure and to prepare for. But hopefully, hopefully we've done a good job in this. So yeah, you can integrate your MPS models in your continuous integration infrastructure and in your version control systems. So the integration part, well, we work hard on this not to be a major obstacle. Okay, well, if you want to, as a first introduction into this domain of language engineering, I recommend the domain-specific modeling book. I think that's a good book to start with if you know nothing about the domain or just very little.
Then about MPS specifically, there are two books to recommend. One of them, MPS Language Workbench reference book. is a book that covers all the details about how to design languages in MPS, the technicalities of how to use the language workbench to design your languages. While the second one, written by Markus Filter, is a direct comparison of 3 language workbenches, and has certain tasks can be accomplished with each of them.
Okay, so that's all the content that I've prepared for this introductory webinar about what is MPS and and what it's good for and who it's good for. Yeah, and Oscar, you promised you've got some questions for me, so now is the time to answer them. And we don't have to rush it, because now I've covered all my content.
Perfect, Václav. Okay, so first I would like to make an announcement. We had some problems with the audio, so I just want to let you know that we will record again tomorrow or the day after, so we can have the whole recording with the correct audio. So sorry for the inconvenience, and I think we can start with the questions. Well, Václav, the first question is, how feasible will it be to have a concept per language to maximize the reuse in language design?
How feasible? Sorry, if I understand correctly, the question was how feasible it would be to have what, a concept
per language to maximize the reuse in language design.
To have okay, that would be kind of challenge to have, like, if I understand correctly, right, to have like one concept in each language. Okay, that would not be very typical and quite a huge overhead. You typically want to wrap things that somehow relate together, to have them, to have them together in one language. Because after all, it's not only the concept but also the interaction of concepts that is important. But technically, I think, yeah, that should be possible. I mean, you can create one concept in one language, another concept in another language, and then make one child of the other if you import the languages. But I think it would become unmanageable. So you have to set the boundaries on a more in a more granular, less granular level than single concept. So that would be my answer.
Okay. So the next question is, what are the future plans for MPS? Are you planning to include more generation targets per default, maybe JavaScript and/or LLVM IR?
All right. Well, we have no concrete plans on that side, although it would be nice, because if you want to generate something that is not Java or C or XML that is supported out of the box, I mean, and C, you can generate C if you get a plugin. Then, other than that, you have to first create the base language, sort of, a copy of the target language, so that you can generate into that one, and this base language will then flush into textual JavaScript, for example. Now, there are open source projects on GitHub for certain target platforms, like JavaScript is there, and it's pretty usable, although the editor is not 100% there, but I mean, the structure is there, TextGen is there, so it's well usable. And other than that, there are not many, or there are none actually that will be like production quality implementations of alternative target languages, I'm afraid. We do not plan to do it ourselves. I mean, no concrete plans. But since this whole thing is open source, anyone can take the initiative and do it and contribute and and implement any language. Or alternatively, you could take the plain TextGen language, which is a plugin that you can grab from the repository, which is a language that models text documents. So you have a concept for line and word and such, and for simple generation of some code, that might be enough. So instead of trying to create a clone of JavaScript or Ruby, you just generate into textual documents. For some DSLs, that might be enough. And other than that, the future plans, well, we're still not happy with how the generator works, so we're making the generator, better. And you might have noticed if you monitor MPS for some time, the generator is getting faster, it's getting more consistent in how it deals with things. And now we would like to introduce or improve on the cross-model generation capability, so that you can freely refer things across models, and the generator can generate these models correctly, including the cross-model references. So we introduced a thing called generation plan, which is an explicit way to declare how the generator should be run, what should be generated when, and it gives you a lot of freedom in how you actually run your generator. And a lot of the inspiration for these changes come from the customers. So, we'll be very happy if people who use MPS and struggle somewhere and realize that MPS doesn't solve the particular scenario, particular case correctly, then, it would be nice to hear about this, so we know and we can adjust the tool accordingly. We're also experimenting with the ability to deploy our languages on the web, but that's too early actually to show anything meaningful at the moment. So currently, if you create languages in MPS, you can have them packaged in a standalone IDE. So you don't have to distribute the whole MPS to your users. They can use an IDE dedicated to the languages that you created. Right? So you could have a language for robot language, for example. You could have an IDE for robot language and just distribute that one. Alternatively, you could use a plugin for IntelliJ IDEA. So if the target audience for you are Java programmers and you want to create a DSL for them to ease whatever configuration of some stuff or whatever, so then you can package your languages as a plugin for IntelliJ IDEA. That's another option. Okay, Oscar.
Okay.
Are there some more?
Yeah, actually there are like a couple of more. So so if you can give a little bit more briefly. It will help. What capabilities or helpers does the MPS offer once the editing part is done? I'm thinking of evaluation, compilation, and step through debuggers.
Sorry, what was the last part?
Debuggers.
All right. Yes. So if you create your language, you create your editors, and then the editors, just by when you define an editor, it's a pretty, it's a static definition with some default behavior, but you might not be happy with that part. So you can customize the behavior of the editor. So you might want to define things like, if the user types this on the right side of that, this should happen. Or if the user presses Control Space here, I want these options to be in the completion menu. Or you can define hints for the user to improve her code. So you can have some code underlined in yellow or red with quick fixes. Please fix this, please fix that. You can provide refactorings. So some capabilities with some keyboard shortcut, the code can be refactored, changed into something else. For the debugger, yes, you can customize the debugger so the user can debug your code. For some languages, it's easier than for others. Where are we? For the robot language, for example, it is quite straightforward because it generates into Java in a very straightforward way. So if you set a breakpoint and run it in a debugger, it will start a debugger and will debug debug the code and set and stop at the breakpoint. Yeah. So now the program stopped, and now I can step over a sideways. So I'm debugging my code, and it was pretty straightforward because this generates into Java directly, and roughly statements here corresponds to a few statements in the generated Java code. If the transformation from your code, from your model to the implementation is less straightforward, you have to customize the debugger yourself. You have to define, what maps to what, so that the MPS can keep track and can actually debug the code. But it is possible to create a debugger. Okay, Oscar, have we covered this question?
Yes, I think so. So, okay, the next question is interesting. It seems the main purpose of projectional language workbenches is for the development and use of DSLs. In the future, do you think they also have the potential to be predominant tool for general purpose languages?
Okay, well, that's a good question. We ourselves, we are sort of thinking about this, right? And it was the original idea when this project started, which was in 2003. And it started as a pure experiment. Let's see what happens, right? If we just shake some of the dogmas. What if code is not text? What will happen, right? And the original idea was maybe it will just change the industry. Maybe now people will just grab languages from the internet, change them to their needs, and if the tooling is right, then it might work. I mean, obviously there are potential problems, right? If you allow freedom in any area, then people might start to misuse it or use it improperly, and you end up with mess, right? So you have to be careful with this. But if the tooling is right, and maybe then it will not be such a problem, you know, to have just little language to use here and little language to use there. So maybe, and the original idea was, yeah, maybe we will make life of Java programmers better this way, because then they can tune Java to their needs. But you know, the software industry is evolving so rapidly, quickly, that that I don't think that this technology at the moment has the potential to make you actually more productive in general purpose language than you know, the existing technology, especially when you rely on, you know, on all the libraries and various tooling, and all the tooling is wrapped around the idea that source code is text. And now if you try to introduce a tool that considers source code to be a tree, so physically an XML document or some binary file on a disk, right? You expect this to be actually loaded into a tool first, and then you can work with it. Now you hit a lot of problems. So we still keep hopes that it might actually be a viable option even for you know, mainstream programming, but probably it will not happen soon, especially because, well, there are two reasons, I think. Well, one of them, and I mentioned that already, is the integration with the existing tool chain and the existing technology. You know, it would have to be more seamless than it is at the moment, in my opinion. So this is one thing. And the second thing is the editing experience. Even though the editor looks like text, it behaves slightly differently. And the more you are used to, you know, how Eclipse or IntelliJ IDEA works, the more you might object a tool that forces you to write code slightly differently. Because even if you code Java in MPS, you feel it feels different than IntelliJ IDEA in several ways. You'll notice that, and you know, people are only willing to accept that pain if there are considerable benefits which currently are not there, at least not yet. So yes, domain-specific languages are the primary focus at the moment, but we believe that the technology has a potential for more. Okay, so that's my answer, Oscar. Do you have some more?
Yeah, we have, for you to know, 6 more. Okay.
Oh, okay, good.
Yeah. Okay. The next one is: Can we then tell that MPS is an imperative language?
No, we cannot. MPS is, I mean, first, MPS you can use MPS to define any sort of languages, even, okay, here we go, a purely declarative, non-imperative language like this one. You know, it's a language to define component dependencies. So I've got a set of components, each component has a name, and then these components depend on one another. So I've got a component called, whatever you call it, foo, right, and the component called bar. Yeah, so you can play with this. You can change names. So these are just components, and then at some point you define dependencies. You know, this component depends on that component. This component depends on that one. So it's purely declarative. There's no imperative code whatsoever. And yeah, you can have that language now generated into what would make sense, right? XML probably. You could generate Java if you could come up with some semantics for this, or maybe just a set of classes and fields referring to one another. Now the semantics would be given by the generator, but here this language is purely declarative, and you can visualize it as text. You can visualize it as a table where you've got the components and the cross marks the dependency. Or you can have a diagram, and in the diagram you've got dependencies expressed with lines. We've got a student working on Haskell implementation in MPS. So Haskell is a purely functional programming language, but there's nothing inherent in MPS that will prevent you from doing that, right? From having a purely functional language defined in MPS. So no, there's no relationship. I mean, no restriction that would only allow imperative domain-specific languages to be created in MPS.
Okay. The next question, you already answered it, but maybe you can add something else. Can you talk a little about the MPS roadmap, and more specific, when we'll have an editor that run on browser?
Yeah. Okay. Yeah. That's a thing I can't actually estimate. We're still working on it. Currently, we're having some early prototypes that we internally discuss and. I mean about the web editing. So nothing that we could publicly show because we don't know yet which way to go. But yeah, we're actively trying to come up with some good solution for being able to edit models in the editor. So basically, have a projectional editor as you know it from MPS. So editor that does not rely on text but run in a browser. Yeah, and as for the roadmap, well, there are gradual improvements to many areas. The generator is the main one, because the generator is currently the single component that's constraining the potential users the most. There are many users who struggle with how the generator can be configured, how it can be triggered, how you can have multiple targets generated. So there are serious restrictions that are inherent from how it had been designed 10 years ago or more than 10 years ago. So we are reducing the generator quite a lot, and yeah, also changing the editor to be more intelligent in how it provides assistance without you explicitly having to say so. A very good move are some people know the grammar cells extension. That is a language extension created by the Embedder team. Embedder is an open source project that builds on top of MPS, and they provide implementation of the C language and a lot of useful utilities for MPS. And one of these utilities is grammar cells that allow you to actually, by defining the editor with special components, you will get a lot of implicit clever behavior of the editor without extra effort. So yeah, we're also trying to improve MPS in that way. We're having a long running internal research on making the type system much more robust and powerful and faster. So these are the key improvements, plus a lot of small improvements on many different fronts.
Okay. The next question is, you mentioned several projects, and some of them use third-party library, like Slison. For what I know, the Slison don't are ready for the new version of MPS, because this dependency we are using MPS 3.4. You know if the Slison project will upgrade to the new version 2017, and if yes, when?
Right. Okay. I can't say when because I don't know. I know that this is an issue that we're trying to solve. We're trying to co-locate their continuous integration with ours, or at least to somehow synchronize these two, so that we know much faster, or they know much faster, if something breaks with our change, so that the migration to a new version of MPS for the libraries, created by the people from Embedder or from Socialisten concretely, who created that, create these utilities, so that the turnaround won't be that long. And yeah, I think it's a shame, and I'm sorry for that. That these are still on MPS 3.4 and not the newer version. I think it's a problem, and I'm not happy about this situation. So we definitely need to do something about it.
Okay, I just want to add something, because I received just a message from the Embedder team, and they said, yes, it will now. So it's, I guess.
Okay, so it's pretty instant. Good.
Yeah, that was really fast. Okay, let's continue with the questions. Any plans for supporting online code editors, and any way we can use MPS constructs with online editors? I guess.
Right. Okay. Well, so that aims again at the editing MPS on the web, right? In the browser.
Yeah.
So
yes.
Yeah, the same answer here, right? Yeah. Currently there's no viable option to do that. So it's one of the problems why I think using MPS for mainstream programming is not likely to happen soon, because, for example, on GitHub, right, when you resolve conflicts or you review pull requests on GitHub, right, you can't review them if they've been made with MPS, because there's no projectional editor on GitHub that would, or at least projectional viewer that would give you, the notations and the editors that MPS has designed for the languages. So you would have to compare XML documents, and that's not feasible. So currently, no. Currently, unfortunately, the integration with browser and editing in browser is not there.
Okay, we just have 2 more questions. Have you heard about using MPS in mobile UI testing? Is it Word to DSL for Q&A and generate tests for mobile platforms?
I haven't heard about that particular use case. I know some of our customers have developed languages in which they can write tests and they generate tests so they can test their code. So using MPS in this way, I mean, to declare test-like languages is a pattern that is quite frequent, but not in this particular case. I haven't heard about a particular case for tests for mobile platform, but yeah, sure, technically that should be possible.
Okay, and now the last question. Can you add more constraints to Java to enforce the style guide?
To enforce, sorry, what?
Style guide.
Right. Yeah. Okay. So to create Java that is more constrained, yes. If you have your users switch from IntelliJ IDEA, but in IntelliJ IDEA you can also constrain the styles and enforce styles, right? So that's probably the easier way. In IntelliJ IDEA you can define static code analysis rules, and they can enforce certain style. You can do the same in MPS. So I mean, the style is actually enforced by the editor. If you define an editor, let me find the right example. So if I switch to a Java piece here, for example, so the editor enforces style, like, for example, the curly brace has to be on the same line where the signature of a method is. You can't move it in here, right? There's just an example. There are 2 styles, right? You can have the 2 styles that people typically adopt one of these 2 styles in Java, either put the curly brace here or they put it on the next line. So with MPS, you have an editor that enforces this. So this is given. You can change the editor, obviously. So you can change the editor so that it shows the curly brace on the next line, and then you enforce that style. So the visualization will be this. Or you can have both and let the users, choose the one they prefer. So if you have a team that consists of 2 groups competing, like one group wants to have the curly brace on this line and the other one wants to have the curly brace on the next line, well, you can create an editor for each, and let them use whatever they like, and don't impact the others. Because if, for example, you prefer one style and I prefer the other, it does not impact the AST. So if you make changes to the code, commit, and I pull your changes, I will have my curly brace where I like it, right? Because the editor is the place where this is defined, the structure of the code. So in a sense, this can resolve the conflicts, if you've got groups that prefer different styles. And it's the editor that enforces the style. Then you've got the capability to create in your language, to create these rules, static code analysis that would report if there are some issues, and you can report some styling issues as well. For example, if you want to never have initializer for a variable, so always variable should be defined without an initializer, and you have to assign it later. Let's say you want to enforce this kind of style. So then, yeah, you can create a rule that will complain each time there is an initializer for a local variable, and it will mark it in red or whatever, and so the project will not compile, if you like. Right? So it will reject, the model checker will complain, sorry, your model doesn't meet the rules. So yes, it is possible to constrain the style of a language. Some of it's done implicitly because of the editor, some of it has to be done explicitly. Okay, so that would be my answer.
Václav, actually there's one extra last question.
Okay, go ahead.
Consider the example you had where MPS generates some Java code. As a programmer, what are the available options for integrating that generated code in the main applications we are developing?
Okay, a very good question. So the thing is, first you can develop that piece in MPS. Let me switch to something that I could use. Okay, so here's a language that generates some Java code. I would like to integrate that with Java code. Now, this code already integrates with some Java code. I've got a library, a runtime library of code that supports the robots, the visual appearance. And so when I run it, it will generate some Java code that relies on Java Swing, and then on my own little library that allows me to draw this and move the robot around. So I've got a little library written in MPS. I could have that same library written in Java, packaged as a jar file, and integrated in MPS. Or I could just import existing Java sources into MPS or Java classes into MPS and then use them in my code. So I could choose. One option would be MPS is the integration point, because I've got libraries, I've got code that someone else created, and I rely on this. So the dependency is solely, from my generated code to going to those. I depend on these libraries. They do not depend on me. So then it's easy. MPS becomes the integration point, and you import that code as libraries, as like this one, right? So other modules in your project will represent Java sources, Java classes, jar files, as you wish, and then you can refer these and use them in your generator or in your code. If you need to depend on, if you on the other hand, if you want to generate code that some other code depends on, then sure, you can do that. You generate, you can pick where the code gets generated. Sorry, here. So you specify where the generated code goes. So the code, as it gets generated, might go to a specific location where the other code will find it. Or you can just generate a jar file from this, right? And that jar file then deploy to the other project. So you can either make the generated code part of the overall code base, or you can just package it all here and then hand it over. Or you can, and that would be probably ideal if you do Java, is to create a plugin out of your language and offer that plugin to IntelliJ IDEA, and then developers can just use Java code side by side the DSL code inside IntelliJ IDEA, and then the generated code implicitly just goes into one location with the handwritten code and compiles together with it. So that is the the most seamless integration for MPS and Java.
Okay, Václav, I just want to make the closing. Well, first
Okay.
I would like to say again, sorry for the audio problems. As I told you before, we're going to make the recording again, so we can have the final recording that we will send to all of you, like complete without a problem of audio. Well, thank you, Baslav, for your time and for all your knowledge that you transmit us.
Okay, it was
And
my pleasure.
yeah. And I just want like to invite you to follow us on Twitter and to follow our blog. And if you have more questions, please ask them in the forum. And okay, I think that's it. Do you want to add some words, Vaslav?
No, I'm very happy that so many people showed up. I hope that content was relevant and informative. And yeah, thank you for joining us.
Thank you, all of you. Bye.
Goodbye.